Hi guys. Okay, let's start with May June paper 1 variant 1 2. Question number 1. Boltzmann distribution of molecular energies and a sample of aqueous hydrogen peroxide room temperature is shown. Now they're saying which diagram Boltzmann distribution of molecular energies of aqueous hydrogen peroxide maintained at room temperature. So they're not changing the temperature. So the curve will not shift. But a catalyst is used. What does a catalyst do? It lowers the activation energy. And therefore, more particles have energy greater than activation energy. And therefore, the rate increases. It can't be C, can't be D, because they're showing a shift in the curve. And if the temperature remains constant, then the curve will not shift. Only the number of particles having energy greater than activation energy will increase. So initially they were this much, now they will increase. And you can see that in B. You see more particles have energy greater than activation energy. Therefore, the answer is B. Can't be A because the particles have decreased here. That doesn't happen. When you add a catalyst, the number of particles having energy greater than activation energy increases. Oxygen has 3 stable isotopes, 16, 17, and 18. All 3 are present in sample of oxygen gas, which was analyzed using mass spectrometer. How many peaks associated with the molecule of oxygen? Oxygen molecular peaks is what they're asking for. So they're asking about the molecular peaks. So let's see. You have 16, 17, and 18. So if you have 2 oxygen atoms, both can be 16. One can be 16, one can be 17. One can be 16, one can be 18. Both can be 17. Both can be 18. One can be 17 and one can be 18. Now let's see their masses. If you add 16 with 16, that would be 32. So this will show a peak at 32. 16 plus 17 would be 33. So there will be a peak at 33. 16 plus 18 would be a peak at 34. 17 plus 17 would be a peak at 34. So this is the same. 18 and 18 would be a peak at 36. And 17 plus 18 would be a peak at 35. So there would be a peak at 32, 33, 34, 35, and 36. This and this would give you the same peak at the same mass. So there are basically 5 total peaks. The most common mistake would have been 6 because you may have not calculated the masses and checked that these 2 would give you the same peak because the mass is the same. So the total of 5 peaks. Question number 3, first 8 successive ionization energies of 2 elements in period 3. So they're in period 3 of the periodic table. Let's find the group number. There's a big jump between the 7th and the 8th ionization energy. So that means that the valence electrons here are 7. So this belongs to group 17 because you have 7 valence electrons. And here you have 2 valence electrons. That means it belongs to group 2. And now one is in group 2, one is in group 17, and they're in period 3. So period 3, group 2 would be magnesium. Period 3, group 17 would be chlorine. The compound would therefore be magnesium chloride. Can't be B because it's calcium bromide. So calcium is in period 4. Can't be sodium sulfide because sodium is in group 1. This is in group 16. This is in group 1. This is also not in. We need a group 17 and a group 2 element. And those need to be in period 3. So that's magnesium chloride. A sigma bond made between 2 atoms carbon in molecule of ethene. So let's see what is the sigma bond between 2 carbon atoms and ethene. So this is ethene. If you see, ethene is sp2 hybridized carbon. The carbon here is sp2 hybridized. You can find that by using the steric number. How many sigma bonds around it? 3. How many lone pairs? 0. Steric number 3, hybridization sp2. So this is sp2. This is also sp2. So they are sp2 hybridized, and an sp2 looks like this. sp2 looks like this. Yes. Can't be A because these are both s orbitals. Can't be B because it's between an s and a p orbital. Can't be D. It's not a sigma bond. This is a pi bond. The answer therefore is C. Do you see this right here is the sp2 and this right here is another sp2 and the orbital overlap between these two such that electrons lie between the nuclei gives you a sigma bond. The answer is C. Question 5. Table shows properties of 4 substances. What could be potassium iodide? So this is an ionic compound. So the melting point would be high. Can't be A, can't be B because the melting points are low. It is a conductor when molten. Yes, ionic compounds are good conductors when molten. So they are good conductors when molten and aqueous. Yes, therefore the answer can't be D because it says poor conductor. That's not true. It will be a good conductor. Answer is C. Question number 6. XYZ are all gases that behave ideally, react according to the equation. 3 mole of X reacts with 3 mole of Y to make maximum amount of Z. Let's see how much Z is formed. You have the moles of both the reactants. One will be the limiting. Let's see. X and Y have the ratio 1:2. So if this is 3 moles, this will be X moles. The next moles come out to be 6 moles. You need 6 moles of this, but you have 3. So definitely this is the limiting reagent. If this is the limiting reagent, therefore the ratio of this will make the product. The ratio is 2:2. So you have 3 moles of this. So how many moles of X, Z will we make? 3 moles. So you have 3 moles of Z. Now, this is in the ratio with X as 1:2. And this is limiting. So if 3 moles of this react, how much of X will react? It will be 3/2. That would be 1.5. So 1.5 moles of X react because X is in excess. So can we say 1.5 moles of X is in excess? So we have 1.5 mole, which is in excess, 3 moles of Z. So the total moles in the container would be, the total moles of gas would be 1.5 plus 3. That would be 4.5 moles of gas. Now let's apply PV is equals to nRT. So PV is equals to nRT. We need to find the pressure. Volume is 1 dm cube. You convert it to meters cube. So 1 meter cube has 1000 dm cube. So 1 dm cube would be 1/1000. So that would be 1/1000. Number of moles are 4.5. Value of R is 8.314. Temperature is 120 plus 273 converted to Kelvin. And when you calculate the value of P, it comes out to be 1.47 10 to the power 7. Which pair of substances are both simple molecular? C60 is simple. Graphene is giant. Iodine and C60 both are simple. Therefore, the answer is B. Can't be C because graphite is giant, graphene is giant. Can't be D, graphite is giant. Question number 8. A reaction pathway diagram is shown. Which row is correct? As you can see, reactants have more energy, products have less energy. So reactants have more energy, products have less. So this is an exothermic reaction. For exothermic, the delta H is always from the reactant to the product. So K right here becomes your delta H. So delta H would be K, can't be C, can't be D. Activation energy of the reverse reaction. Forward is exo, reverse would be endo. And for endothermic reaction, the entire thing is the activation energy. So O would be your activation energy. Therefore, the answer is K for this and O for this, that is B. Question number 9. X is either chlorine or oxide of chlorine. X reacts with water under suitable condition to form 2 acids, HCl and HClO3 in the ratio 1:5. Let's see. So you have chlorine reacting with water. It makes HCl and HClO3. Now they need to be in the ratio of 1:5. Let's see if the balancing is correct. If this is 1:5, let's see. You have 5 plus 1, 6 chlorine here. So you will put a 3 here. Then you have 5 plus 6 hydrogen here. So you will put a 3 here. You have 3 oxygen here, but you have 5 3s are 15 oxygen here. You see, it doesn't balance out. This can't be the answer. Cl2O. Cl2O with water making HCl and HClO3. So they're supposed to be in 1:5 ratio. So let's keep the ratio 1:5 and see if it balances out. So you have 1 and 5, 6 chlorines here. So you will put a 3 here. Then you have 2 hydrogen here. Then you have 1 and 5, 6 hydrogen here. So you have 2 here and you have 6 there. So you put a 3 here. Let's check the oxygen. You have 3 and 3, 6 oxygen. And over here you have 15. Doesn't balance out. Can't be the answer. Let's check with ClO2 plus water. So ClO2, you have 1 Cl here and you have 6 Cl here. Put a 3, 6 here. Then you have 1 plus 5, 6 hydrogen here. Put a 3 here. Let's see the oxygen. You have 6 2s are 12. 12 plus 3, 15 oxygen here. And you have 15 oxygen here. Yes, it balances out. Answer is C. Ethyl ethanoate undergoes the following reaction. Now they've given you the Kc and they've told you at equilibrium, concentration of ethanoic acid and ethanol at equilibrium. So at equilibrium, ethanoic acid and ethanol both are 0.42. Yes. Now we don't know what is this, but we know the ratio is 1:1. So if this is X, this will also be X. We know Kc would be concentration of product, that would be 0.42 square, because it's 0.42 and another 0.42 divided by X times X. And Kc is given to you, which is 0.27. And then you need to find your value of X. You need the concentration of ethyl ethanoate. You need this value at equilibrium. So when you find the value of X, it comes out to be 0.81. So that is C. Question number 11, which is an example of heterogeneous catalysis. Heterogeneous is when you have different physical states of the reactant and the catalyst. Let's see. First example, esterification. In esterification, sulfuric acid is aqueous, and so is ethanol, and so is alcohol and acid. Can't be the answer. It's homogeneous. Contact process. In contact process, you have sulfur dioxide with oxygen becoming sulfur trioxide. Both reactants are gaseous. V2O5, that is your vanadium pentaoxide. This is not gaseous. The answer therefore is B. Destruction of ozone. In ozone, you have chlorine radicals, which are chlorine gaseous atoms, and ozone is also gaseous. Formation of sulfur trioxide with nitrogen dioxide. So this is also gaseous, and sulfur trioxide and sulfur dioxide are also gaseous. So can't be the answer, can't be the answer. Answer is B. Q, readily oxidizes in air. Oxide produced reacts with water to form a solution of a very low pH. So very low pH means acidic pH. Now, if it is very low pH, that means it's a covalent oxide, and a covalent oxide must be from non-metallic group. Yes, because metals give ionic oxides and they are basic. But this decreases the pH and it's very, very low. So as we go from group 1 to group 2 to 13 to 14 to 15 to 16, the acidity of the oxides increases. So the most acidic oxide would be group 16, which is not the option here. So the next best or the most acidic would be 15. The answer therefore is D. Question 13. 8 elements, sodium to argon, are in the same period of the periodic table. The equation corresponding to the first ionization energies is shown. Which of these 8 elements the electron is removed from a filled orbital? Filled orbital means fully filled orbital, because otherwise they would have said partially filled. They mean fully filled orbital. So let's see. You have magnesium. They haven't written sodium in any of the options, so I'm not going to do that. So magnesium, then you have aluminum, silicon, phosphorus, sulfur, chlorine, argon. Magnesium has outer electrons in 3s2. This is 3p1, 3p2, 3p3, 3p4. This is 3p5, and this is 3p6. Magnesium loses from 3s2. Is this fully filled? Yes. So magnesium does. A can be the answer. Let's see. Because magnesium is correct. Let's see aluminum. Aluminum loses from 3p1. It loses this electron. Is this from fully filled? No. Can aluminum be correct? No. Therefore, A can't be the answer because aluminum is wrong. B can't be the answer because aluminum is wrong. Then let's check. Magnesium is correct. And we know magnesium is correct. Therefore, the answer is C. Can't be D because D does not have magnesium as an option. Let's check the other options here, S, Cl, and argon. Let's check those as well. So sulfur is 3p4. So 1, 2, 3, and 4. So you see, you lose this electron, the fourth one that you add, and this is from a filled orbital. So sulfur is also correct. Chlorine is 3p5. 1, 2, 3, 4, 5. So you lose this fifth one, which is again from a filled orbital. Chlorine is correct. Argon is 3p6. 1, 2, 3, 4, 5, 6. So it loses the sixth electron again from a fully filled orbital. This is also correct. Answer is C. Element D and E are both in period 3. Element D has the smallest atomic radius. So you know across the period the radius decreases. So the smallest atomic radius would be of chlorine. Yes. So we know it will be chlorine. They've given sulfur and they've given chlorine. Between chlorine and sulfur, chlorine is smaller. So B and C can't be the answer. Then there are only two elements in period 3 which have lower melting points than element E. So we figured out that D is chlorine. Let's figure out E. For that, we need the melting points. So let's see period 3 melting points. Let's see the trend in melting point. So you have sodium, magnesium, aluminum. Then you have a big jump, silicon, because silicon is a giant macromolecule. Yes, and then there's a decrease, P4, then there's S8, then there is chlorine, and then there is argon. Yes. Now, they've given E as either phosphorus or magnesium. And they're saying that E, there are only two elements in period 3 which have lower melting points than E. So if E was magnesium, then you not only have two, but you have sodium, you have phosphorus, sulfur, chlorine, argon. All of these have less melting point compared to magnesium. So A can't be, E can't be magnesium. Yes, therefore E would be phosphorus. Do you see only two elements have energy melting point less than that? Chlorine and argon. And therefore the answer is D. How many solutions of shown when added to separate portions of magnesium sulfate will produce a white precipitate? When you add this to magnesium sulfate, you will get magnesium chloride. Yes, and magnesium chloride and sulfuric acid. So you will have this magnesium chloride is not a precipitate. This is also not a precipitate. Let's see this with ammonia. When you add it to ammonia with magnesium sulfate, so it's aqueous ammonia, as you can see. So ammonia with magnesium sulfate, that means you also have water. So from the water, from the H from water, ammonia will accept the H because ammonia has a base. It's a proton acceptor. So it will accept the proton from water and become ammonium sulfate. And you will be left with magnesium and OH. So that will become magnesium hydroxide. Yes. Now, ammonium sulfate, again, not a precipitate because all ammonium salts are soluble. Magnesium hydroxide is a precipitate. Then let's see ammonium carbonate with magnesium sulfate. So that will make magnesium carbonate and ammonium sulfate. Ammonium sulfate is again soluble. This will not be a precipitate because all ammonium salts are soluble. Magnesium carbonate will be a precipitate. Barium nitrate. When you add this to magnesium sulfate, you will get barium sulfate and magnesium nitrate. Magnesium nitrate again is soluble, but barium sulfate is a precipitate. So you have a precipitate of magnesium carbonate, barium sulfate, magnesium hydroxide. Therefore, you have a total of 3 precipitates. White solid Z is soluble in water. So let's see which of these will be soluble in water. Carbonates are insoluble, can't be the answer. Nitrates are soluble, so the answer can be B or D. Now, when you heat it, so when you heat this, it will decompose into magnesium oxide, 2 moles of NO2, half a mole of O2. This will decompose into barium oxide, 2 moles of NO2, half a mole of O2. So they say when you heat it, the resultant residue is shaken with water. So if you shake this with water, to oxide, if you add water, you get hydroxide. And magnesium hydroxide will be a precipitate. This will give you barium hydroxide, which will be a clear solution because it is soluble. So they are saying you get no solid remaining. Magnesium hydroxide will give you a precipitate. So therefore, this can't be the answer. The answer is D. Excessive chlorine is bubbled into 100 cm cube of hot sodium hydroxide. So the equation for chlorine with hot NaOH is chlorine, 3 moles of chlorine with 6 NaOH becoming 5 NaCl plus NaClO3 plus 3 moles of H2O. Right here is the equation for chlorine with hot NaOH. Let's convert this to moles. So you do N is equals to C times V. Concentration is 6. Volume is 100 upon 1000. So you convert it to dm³. So it's 6 times 100 upon 1000. And the moles come out to be 0.6. So the moles of NaOH are 0.6 moles. They want you to find the moles of sodium chloride. So the ratio is 6:5. If this is 0.6, this will be X. So you multiply it by 5 divided by 6, and the moles come out to be 0.5. The answer therefore is B. Question number 18. Ammonium sulfate and ammonium nitrate are used as fertilizers. These salts are used as fertilizers. These salts have different percentages by mass of nitrogen. They have same effect as each on other on pH or wet neutral soil. Let's see. So you are adding ammonium nitrate and ammonium sulfate. Let's see which one has more nitrogen by mass. So in ammonium sulfate, you have 2 moles of nitrogen. So that will be 14 times 2 divided by the total MR. That will be 14 times 2 plus hydrogen is 4 2s are 8. Sulfur is 32.1, 16 times 4. So that is going to be your percentage of nitrogen in ammonium sulfate. In ammonium nitrate, you will have 14 times 2 divided by 14 times 2 plus 4 hydrogen, so times 4 plus 4 plus 16 times 3 for the 3 oxygen times 100. So clearly the denominator is smaller here. This will have more percentage as opposed to ammonium sulfate. So ammonium nitrate has more nitrogen by mass. So it can't be C, can't be D. Now, what will be the effect on soil, on neutral soil? They are both going to give ammonium ion. Ammonium ion is a conjugate acid. So since it's a conjugate acid, it will decrease the pH of soil. Moving on, question 19. Which gives a product that is an atmospheric pollutant? So let's see, does this cause atmospheric pollution? No. These, nope. These, nope. Answer is therefore D. As you can see, sulfur dioxide and sulfur trioxide, we know they can result in acid rain. Question number 20. Let's see. So you have this right here. It's a double bond alkene. You do reaction 1. In reaction 1, alkene becomes an alkane. So what is this? Electrophilic addition of hydrogen. We also call this what? Reduction. So it can't be A, can't be B because they say oxidation. That's not true. It'll be reduction. In 2, alkene becomes a chlorine, a Cl here and a Cl here. This is again electrophilic addition of halogen. The answer therefore is C. Clear? We'll do the remainder of this in the next video.